All right, for this lab, we will complete our implementation of singly linked list and a doubly linked list. We did not do a doubly linked class, but we did pretty much all the singly linked list. We just didn't templatify it. So you just need to add the templates to it. I hope that'll be a good exercise. You did it once with the array, or we did it with the array. We can do it again with the linked list. I think I've given you some boilerplate code in the lab. Let me find out. Yep, there it is. Look at all that. It's even commented. Oh, there, look at that. Okay, so I went and did a lot of it for you right here. Ooh, that's gonna be fun to talk about. Default constructor, we already did that. We did not write this one, but you'll need to think about it. We did not write this one either, but we definitely talked about it. Get length, again, we talked about it. Append, insert at the, oh, this one's at the end of the list. All right, gotta put it at the end. Insert, hey, we did that one. Spoiler, it might be easier if you go do insert first and then do get length, and then maybe append won't be so hard. Just throwing that out there. I am not grading print. You do not have to have print implemented. Here's remove. Remove the first instance of val. So it's like the code in the class. If there's more than one instance, you only remove the first one, not any of the other ones. So it's not remove all. It's really remove first instance of. But that's way too much typing. So just remove. Okay, here we go. This is a good exercise. I know I've been saying operator overloading is dumb, but this is good to look at. The subscript operator. This is going to make it look or behave like an array. For a linked list, this really doesn't make sense, but I wanted to show you why pretty much the array is the only one that likes to use this subscript. Okay, there's another one, but in this case, what you're doing in pose, you're going down pose position and then returning the proper value. If pose is beyond the bounds of the linked list, let it segfault. Don't try and return null or something crazy, just let it segfault. All right? Because just like an array, if the bounds are incorrect, it segfaults. Do that here as well. Operator double equal, just check the two are contained. And then you literally do the exact same functions, but a doubly linked list. Same exact thing. Again, doubly linked list, pointer going both ways. You're going to need to create nodes for that. Make sure you test it. Yes, I know if you copy your singly linked list code, call it doubly linked list, pass it to the autograder is going to pass both of them. But then when I check your code, I will of course take off points for the doubly linked list. All right? All right. I know I just gave you a project, but unfortunately we have some very, very important questions. Good. These are just questions. You don't have to generate the performance graph. Just questions. What is the performance difference between append, between array, singly linked list, and doubly linked list? Think about the big O. How about insert? Again, think about the big O. What's the performance of the subscript operator between the big ones? All right, that one should be pretty obvious, or hopefully should be really obvious after you implement the singly linked list subscript operator. There we go. Let me try not to say the word obvious too many times. What's the performance difference for remove? For search, please answer these comments in a text file or a doc file. All right. Any questions? Oh, it's due a week from today, right? Good, a week from today. Okay. Yes.
So when it's asking the performance difference for remove in the array, is it just delete that value or delete the value and then move everything over?
Move everything over.
Okay.
That's the problem, isn't it? That is the problem. You have to shift everything down. You don't have to do that in a linked list. Yep. Any other questions? All right, that is all for today. Have a good weekend.